Hello viewers, in today's class we are going to discuss one important definite integral involving the greatest integer function and the signum function, right? So here we have to solve this integral that is from 0 to pi by 2, and here we have greatest integer of e raised to signum of x minus pi by 3, right? So here the important thing is that we have two important functions in mathematics, that is the greatest integer function and the signum function, right? So let us solve this integral, and let us first call this integral as I, right? Now before proceeding further, let us quickly revisit the definition of signum function, right? Now see, we know that signum of say y is equal to plus 1, that is signum of y takes the value plus 1 for all y greater than 0, right? And signum of y takes the value 0 when this y is equal to 0, right? And signum of y takes the value minus 1 whenever y is less than 0, right? So here we'll make use of this definition to explain signum of x minus pi by 3, right? So now signum of x minus pi by 3 can be written as, see, here we replace y by x minus pi by 3, right? So signum of x minus pi by 3, it would take the value plus 1 whenever x minus pi by 3 is greater than 0, right? And signum of x minus pi by 3 takes the value 0 when we have x minus pi by 3 is equal to 0, and signum of x minus pi by 3 takes the value minus 1 whenever x minus pi by 3 is less than 0, right? Now if we solve this inequality, we'll get x greater than pi by 3, and if we solve this equation, we'll get x is equal to pi by 3, and this inequality gives us x less than pi by 3, right? Okay, so this is all about signum of x minus pi by 3. Now let us see the limits. So here the lower limit is 0 and the upper limit is pi by 2, right? So let us represent the limits on this number line. So here we have 0, and here we have pi by 2, right? Okay, now see, pi by 3, this point x is equal to pi by 3, it lies between uh, 0 and pi by 2, right? So here we have pi by 3. So what we will do, see here we have the greatest integer of e raised to signum of x minus pi by 3, right? So what we will do, we'll first consider the signum function. So what we will do, we'll write I is equal to 0 to pi by 3. So we'll split this integral as a sum of two integrals, because here pi by 3 is the point where we can split this integral from 0 to pi by 2. So here we'll write greatest integer of e raised to signum of x minus pi by 3. So 0 to pi by 3, when we are going from 0 to pi by 3, so this portion, all the points are less than pi by 3, right? So when x is less than pi by 3, we have a signum of x minus pi by 3 is equal to minus 1. So here we'll get minus 1, right? Okay, then we'll write pi by 3 to pi by 2, right? So in this portion, when we go from pi by 3 to pi by 2, x is greater than pi by 3, right? So we can now write e raised to plus 1 here. Why? Because signum of x minus pi by 3 takes the value plus 1 when x is greater than pi by 3, right? So now we have these two integrals. So now we have to calculate the values of greatest integer of e raised to minus 1 and the greatest integer of e raised to 1, right? And here e is the famous exponential number, right? So let us first consider e raised to minus 1. Now see, we know that e lies between 2 and 3, right? So when e lies between 2 and 3, then we have 1 over 3 is less than 1 over e, and 1 over e is less than half, right? So if we take the reciprocal of 2e and 3, then we'll get this inequality, right? So here we have 1 over 3 is less than e raised to minus 1, and this is half, right? So e raised to minus 1, it lies between 1 over 3 and half. So 1 over 3 is approximately 0.33, and half is 0.5, right? So by definition of greatest integer function, the greatest integer of e raised to minus 1 must be equal to 0, right? And if we take this greatest integer of e raised to 1, then e is approximately equal to 2.71, right? So the greatest integer of e is equal to greatest integer of 2.71, right? And this is equal to 2, right? So now I becomes 0 to pi by 3, and here the greatest integer of e raised to minus 1 is 0. So this integral would become 0, and here we have pi by 3 to pi by 2, and here we have 2 for greatest integer of e, right? So now this integral is 0, and here we have 2 times pi by 3 to pi by 2, and here we have dx. So this is 2 times the integral dx is equal to x. So here we have x, limits are pi by 3 to pi by 2, and now we can write 2 times. Here we'll substitute the limits and we'll take the difference. So we have pi by 2 minus pi by 3. So this is 2 times 3 pi minus 2 pi over 6, right? And this is 2 times pi over 6. So this is pi over 3, right? So the value of this integral is pi over 3.